Here we go. Are we having fun yet? I can't think of anything better to do here. Moving to the next question, give an example of a set of data for which the R value is close to -1, but for which there is not a strong relationship between X and Y. Now just a few reminders. R value is typically between -1 and 1. -1 what usually indicates a very strong negative linear relationship, and +1 usually a strong positive relationship. And R values in the middle near 0 indicate we hope indicate no real relationship. Now there are exceptions to all of that. One of those would be in the case of outliers. If we had a bunch of data all over the place over here, so there would appear to be no real relationship there. They're kind of all scattered, no clear trend. But I were to put one outlier far over here, when I look at the relationship, because of this outlier in the picture, it makes it look like there's a strong negative trend. So the R value would be maybe close to -1, something like -0.9. However, without this one data point, as you saw earlier as I drew it, when we only look at this part of the picture, there does not appear to be any strong relationship in the data. So you should watch out for that case. Some other things just to remind yourself of. You can get an R value close to 0 in the case where there is no relationship whatsoever. They're scattered all over the place. Or you can get an R value close to 0 sometimes when there is a nonlinear relationship. And a third case, this one doesn't happen very often, but it would be if your data was in a vertical line or if your data was in a horizontal line. Either one indicates no relationship between the data points. So whenever you use an R value, do be careful. Typically an R value close to 1 or -1 means a strong relationship, but there are exceptions. And typically an R value close to 0 indicates no relationship, such as this one. But it can also indicate this case where there is some other nonlinear relationship, or something like this where, well, truly no relationship because the X does not influence the Y. Next question is looking at the least squares regression line. Now this is a great question. The least squares regression line is used to describe the linear relationship between two quantitative variables. Now there are some issues you should watch out for when using a regression line. Whenever you're using a regression line, you must always check the following. And if you don't have the following information, you don't have any confidence as to the quality of the fit of the trend. First is you need to check the R or R squared value. Remember, R squared is the percent of variation explained by the linear regression. It doesn't tell us the direction of the slope, positive or negative, but it tells us the percent that's explained. The R tells us the direction, but it doesn't have a nice interpretable meaning, although close to 1 is typically strong relationship, except for the case we just talked about, and close to 0 is a weak relationship. So you want to check for a good R value. Second thing you should always check when using a least squares regression line is for the presence or lack of outliers. Those can highly influence the R value and the regression line and may lead to strange results. Third thing you should always check is check for nonlinear relationships. These would be things like parabolas or sines and cosines or exponential functions. Before you try and fit it with a line, you want to make sure a line is really the right thing. And the last thing is, you're using a regression line, you should always check to make sure that you are not extrapolating. All right, moving on to the 9th question. Why is it important to use a random sample? Now, we talked about some issues dealing with sampling. One of the big issues was bias. And if you recall, we talked about one example using convenience sampling, where suppose you were trying to find out how much people like eating at the cafeteria. You may stand outside up near the cafeteria and pass out surveys, and it may seem like you're randomly giving those out. However, if you look more closely, because of where you are at, there's probably a higher number of people going and coming from the cafeteria. And if they're going or coming from the cafeteria, they are already making the decision to go there, which means they must like it more than maybe people who don't go, who decided they don't like the food and don't want to eat there. So even though your sample looks random, the people are not. You're over-representing the group who likes the food and would get biased results. And that was an example of convenience sampling. There are other reasons for bias. Random sample eliminates that. What a random sample does, a random sample gives everyone in the population the equal opportunity to be in the sample. So everyone has an equal likelihood of being in the sample, which means that you have fair representation. And not only a fair representation, but a fair representation of all groups in the population. And that's important for making sure that your sample really represents everybody there. And I would strongly encourage you on that one to try and phrase this in your own words. I think it's really important to be able to articulate this. If you want, call up your parents right now, tell them about this awesome class you're taking, and tell them that one of the things you learned is why being random and taking random samples is so important. I'm sure they'll appreciate that all their money is going towards a good cause.